So this assignment which is related to rate, redox, and the reversible reactions. You will find this topic MCQs in Unit 2 as well as the structure questions. The first 18 I have already solved, so we'll start with question 19. Question 19, related to exercise, rate, redox, and reversible. Consider the following ionic half equations are there. So we have aluminium is turned into aluminium ion by loss of electrons, so which is oxidation. And we have two hydrogen ions are there. They are taking two electrons, gaining electron and turn into hydrogen molecule, which is a reduction. We want to write the combined equation. How to write a combined equation? If we have oxidation and reduction halves, how to write the final combined equation? We make the number of electrons same. So how we can make the number of electrons same? The first equation, we have 3 electrons. The second equation, we have 2 electrons. So what we will do, we'll multiply our first equation by 2 and we multiply our second equation by 3 because we want to make the same number. And then we add the two equations, so electron will cancel out. So when we multiply the first equation by 2, so this will become 2Al gives 2 aluminium ions plus 6 electrons. And the second equation we multiplied by 3, so it will become 6 hydrogen ions plus 6 electrons gives 3 water molecules, 3 hydrogen molecules. Now when we add these two equations, electron will cancel with electron. So what is there before the arrow? That is a reactant. So we are left with, if I write here, so we are left with 2 aluminium plus 6 hydrogen ions will give 2 aluminium ions plus 3 hydrogen. So which match with option aluminium plus 6 hydrogen ions give Al3 plus 3. So it match with option C. So whenever we have ionic half equations and we want to write a combined equation, the simple rule is you make the number of electrons same and you add the two equations. This question is about the Maxwell-Boltzmann energy distribution. The diagram is for increasing a temperature. So when we increase the temperature, what will happen? The peak, like the Maxwell-Boltzmann distribution graph shows the energy of the particle and the number of particles have certain energy. If we increase the temperature, what will happen? Greater number of particles have energy more than activation and the peak will decrease. So if T1, like starting T1 is smaller temperature and T2 is a higher temperature. So what should happen? The peak should decrease and more particles shifted towards the right-hand side. So when we check this one, the peak, the height is not changing. So this cannot be an answer. Here the peak decreases and it shifted towards the right-hand side. So B is the, why not C? C shows that the average energy of the particle, like greater number of the particle have energy fraction that the total area is changing. That is impossible because the total area gives the number of the particle. So total area cannot be changed. So if the width is increasing, then the height should decrease. If the height is increasing, then the width should decrease. And this is totally shows that the T2, the fraction of the particle with energy is decreasing. That is also wrong. So B was the right answer. Question 21. Potassium iodate 5 can be produced from an iodine and the potassium hydroxide. Give the oxidation numbers of iodine in the iodine containing species. Hence classify the reaction. Okay. So first, this is iodine. And because it's an element, so what is the oxidation number of the element? The oxidation number of the element is always 0. The next one is potassium iodide. We need for iodine. So iodine is X and potassium is group 1, so +1. And because it is a molecule, so the net oxidation number should be 0. So plus 1 plus X should be 0, or X is equals to minus 1. So in this case, the iodine oxidation number is minus 1. In potassium iodate, KiO3, we need for iodine. So iodine is X, each oxygen is minus 2, potassium is plus 1. So this will be plus 1 plus X minus 6 is equals to 0. Why? Because 3 oxygen are there. So each oxygen is minus 2, 3 will be minus 6. So when we simplify this, we have like plus 1 plus X minus 6, 0, or X is equals to, because plus 1 minus 6 is minus 5, so X is equals to plus 5. So here oxidation number will be plus 5. So you can see in this case the 0 become minus 1. If the 0 has turned into minus 1, so what we call this change? We call this change as a reduction. And 0 become plus 1, so this change is called oxidation. So for a reaction in which the same element is oxidized and reduced, what we call these type of reaction, we call that as disproportionation reaction or disproportionating reaction. Whenever the same element is oxidized, because usually simple redox reaction, one element is oxidized, the other one is reduced. In question 22, this is a multiple choice question, which is related to reversible reaction. This question is about the equilibrium or the balance when between a hydrogen and a carbon dioxide. What effect would the following changes have on the rate of a reaction and the yield of carbon monoxide? Means yield of carbon monoxide means the amount of carbon monoxide, which is a product, and the rate of reaction. If we decrease in temperature from 700 to 600, so rate of a reaction depends on what factors affect the rate. Rate is affected by concentration, rate is affected by surface area, rate is affected by temperature, rate is affected by pressure, rate is affected by catalyst, and some of the reaction, the rate is affected by light, photochemical reactions. So in this case, we are all of them, if we increase any of them, the rate will increase. But here we are decreasing a temperature, so the rate should also decrease. So rate decrease, either B can be an answer or C can be an answer. The equilibrium or the balance can be affected by changing concentration, can be affected by temperature, can be affected by pressure. These are the factors which can shift the equilibrium. Because the enthalpy change is positive, means this reaction is endothermic. So if it's an endothermic reaction, the reactant will have less energy and the product will have high energy. What we are doing, we are decreasing a temperature. So if we are decreasing a temperature, we reduce the energy. So if a temperature for endothermic reaction, if we decrease the temperature, equilibrium will shift toward the left-hand side or the yield will decrease. And if we increase the temperature, the equilibrium will shift towards right or the yield will increase. So as we are decreasing a temperature, we'll get more reactant. So as we get more reactant, amount of a product or a carbon monoxide will decrease or a yield will decrease. That's why B is the valid answer. If we increase the pressure, increase in pressure also, as I mentioned, if we increase the pressure, what is the effect of the pressure? Increasing any of this factor increases the rate. So either A can be an answer or B can be an answer for this one. But what about the yield? How the equilibrium yield is affected? When we increase the pressure, if a pressure is increased, it will shift towards side. of less moles of a gas. And if we decrease the pressure, it will shift towards side of more moles of a gas. So we are increasing the pressure. So as we increase the pressure and we check the moles of a gas, 1 mole here and 1 mole here, so total 2 moles, 1 mole of a gas here and 1 mole, so total 2 moles. So we have equal number of the moles. So if we have equal number of the moles, then of a gas, moles of a gas, then the pressure will not affect the equilibrium. So there is no effect on the yield. So that's why B is the right answer. So if we increase the pressure, rate of the reaction will be faster, but the amount of a product does not change as we have equal moles or equal number of moles of gas. If one of them was not gas, like example, what if this water was produced in a liquid state? Then we'll have 2 moles and 1 mole. Then if we increase pressure, the equilibrium will shift towards the side of less moles of a gas. So it will form more carbon monoxide. But because water vapors are there, so we consider them as a gas. So we just count the moles of gas. A Maxwell-Boltzmann curve shows the distribution of molecular energies in a reaction system. When the temperature in this system is decreased, the peak. So if we have a Maxwell-Boltzmann distribution graph, if this was a graph, and now we are decreasing a temperature. So if we decrease the temperature, the average energy in the particle with a greater proportion of energy will also decrease. So where the peak will shift, if we decrease temperature, it will shift towards the left-hand side. And if we increase temperature, where the peak will shift, it will shift towards right-hand side. So this is the effect of increasing a temperature, and this is the effect of decreasing a temperature. So when the temperature in the system is decreased, the peak is higher and it is further towards the left-hand side. So that's why B will be the right answer. Which of the following substances does not form when few drops of sulfuric acid is added to potassium bromide? So potassium bromide, bromidine is good reducing agent. Like when we compare the reduction power, iodine reduce more, like better reducing agent than bromide, and bromide is better than chloride. So when iodine is reacting with sulfuric acid, it will result in a formation of products with a lower oxidation numbers, like it can produce sulfur dioxide, it can produce sulfur, it can produce hydrogen sulfide. When it produces sulfur dioxide, here sulfur is +6, here sulfur will be +4, sulfur will be 0, and sulfur will be -2. So these products can be formed like the lower oxidation number. But when bromide is there, so when bromidine is not compared to iodine, it is a weak reducing agent. It will also reduce sulfur, so it will produce sulfur dioxide, it will produce sulfur, but it is not able to produce hydrogen sulfide. That's why B is the right answer. Because the first reaction, as we discussed in the group 7 reaction, the potassium bromide KBr, when it reacts with sulfuric acid, first reaction is an acid-base reaction. It will produce potassium hydrogen sulfate plus hydrogen bromide. And this HBr is there, reacted more with sulfuric acid. The second reaction is a redox reaction, which result in a formation of multiple products of sulfur. So hydrogen sulfide is only produced when we have iodine, which is a good reducing agent as compared to chloride or bromide. Oxidation number of a sulfur in potassium aluminium sulfate. So we have potassium aluminium sulfate. which is also hydrated. So 12 water molecules are there. So we don't have to bother about the water molecules. Now we need the oxidation number of aluminium. So we have K, Al, SO4, and then 2. And in this oxidation number of a sulfur we need, like what should be the charge or the oxidation number of a sulfur? So how to do this question? As because the overall compound is there. So first, aluminium is plus 3, potassium is plus 1. So what we want the oxidation number, because the overall compound, and this 2 is representing the net charge on this, like when we cross multiply, this 2 will be there. And for sulfur, we have SO4. Now, each oxygen is there. See, and the overall compound, the net charge on this compound should be 0. Now, each sulfur is X. We don't know the sulfur. So each sulfur is X, but because the bracket 2 is there, so this will be 2X. And each oxygen is minus 2, but how many oxygen are there? 4 multiplied by 2 makes 8. And this will be minus 16. Why 16? Because like 4 multiplied by 2 makes 8. And each oxygen is minus 2. So 8 into minus 2, that will give minus 16. And the result should be 0. So means plus 1, plus 3, plus 2x, minus 16, the net charge should be 0. We did not consider water because it's a this part of a molecule is neutral, so we can work out from this. When we simplify, this is plus 3 means plus 4 minus 16, so this will be 2x minus 12 is equals to 0. 12 will go other side, so 2x is equals to 12. If we need x, so x is equals to 12 divided by 2, which is equals to plus 6. So C should be the right answer. Is it clear? Question 25, how we work out the oxidation number of sulfur. Then 26, PCl5 reacted with chlorine, PCl3 reacted with chlorine, give PCl5. In which of the following with both stated changes increases the amount of a product present at equilibrium? This is a reversible reaction and the forward reaction is exothermic. So what we want to increase the amount of a product, or we want to shift the equilibrium towards the right hand side. So if we have a reversible reaction which is exothermic, for exothermic reactions, if we increase the temperature, equilibrium will shift towards the left hand side, or amount of a product or the yield will decrease. And if we decrease the temperature, equilibrium will shift towards the right hand side, or amount of a product will increase. So what we should do for the temperature, we should decrease the temperature because we want more product. And what about the pressure? When we check, we have 1 mole of a gas here and 1 mole, so total 2 moles and total 1 mole. So we want the equilibrium will shift towards the right hand side. So we should increase the pressure, because whenever we increase the pressure, it will shift towards the side of a less moles of a gas. So we should prefer, because the less moles are on the right hand side, so we prefer increasing pressure and decreasing temperature. So decrease temperature and increase the pressure will increase both. Changes will increase the amount of a product or shift the equilibrium towards the right hand side. Consider the following simplified equilibrium for an indicator, like they give a molecule of indicator. Addition of a few drops of sodium carbonate. So when sodium carbonate is there, Na2CO3, acid can react with carbonate. So what will happen? This hydrogen ion will react with carbonate. When this hydrogen ion will react with carbonate, so amount of a hydrogen ion in the solution will decrease. If the amount of hydrogen ion in the solution will decrease, where the equilibrium will shift? Equilibrium will shift towards the right hand side. Because how the factors affect the equilibrium, if we add reactant or we remove product, equilibrium will shift towards the right hand side. And if we add or if we remove reactant or we add product, equilibrium will shift towards the left hand side. So what we have to do, we have to check what happened here. If we add sodium carbonate, so we have to check which substance sodium carbonate can react. Sodium carbonate can react with acid. So what is acid here? The hydrogen ion, the protons. So when they react with acid, the amount of hydrogen ion in the mixture will decrease. If amount of hydrogen ion in the mixture decrease, like it means we have removed the product. So as we remove the product, where the balance will shift or equilibrium will shift, so equilibrium will shift towards the right hand side. So when the equilibrium will shift towards the right hand side, what will happen in this reaction? So it will make more purple, make the equilibrium mixture more purple, because this is yellow and this one is purple. If we get more like equilibrium shifted towards the right, so more purple substance will form. That's why D will be the right answer. So whenever these type of questions are there, you have to check which reagent, either reactant side or a product side, the substance which is added can be reacted. So this was question 27.